For the trigonometry identities tonight, we have cotangent theta plus 1 over cotangent theta is supposed to equal cosecant of theta times secant of theta. And we are going to leave this side of the equation alone and only work with this side for now. So we can start by using our identity for cotangent as being cosine theta over sine theta. And 1 over cotangent theta is the same as saying just tangent theta, which in turn is cosine over theta or sine plus, and then we know tangent of theta is sine theta over cosine theta. From here, what we're going to do, we need to make our denominators equivalent. So to make them equivalent, we're going to multiply this first fraction by cosine over cosine, which is really just multiplying it by 1. And then, so that we have a cosine theta, sine theta in the denominator, we're going to multiply this one by sine theta over sine theta, which would then give us cosine squared theta over sine theta cosine theta plus sine squared theta over sine theta cosine theta. Now I'm going to use my Pythagorean identities to look at this, the numerator, which is cosine squared plus sine squared, and I know that to be 1. And then we're just going to go ahead and keep the denominator as sine theta cosine theta, because when you're adding fractions, the denominator stays the same. And 1 over sine theta is cosecant of theta, and then 1 over cosine theta is secant theta, and there you have your answer. The next one we have secant of x over cosecant of x plus cosecant of x over secant of x should equal cosecant of x times secant of x. And this one, to get to the next step, is complicated, but once you get past that, it is just like we did with the first problem. So I'm going to break each term down into individual parts. So this one is the only thing we're going to work with first. Secant of x, I know, is 1 over cosine of x. This is a division sign, really, so I'm just going to put my division sign in there. I'm just going to break this down as simply as possible. And I know that cosecant of x is 1 over sine of x. So now, since I'm dividing fractions, I have to multiply by the reciprocal. So I'm just going to rewrite this part right here as 1 over cosine of x times sine of x over 1, which really, and again, we're still talking about this term, resulted in all of this work. And if you can do it in your head, you can just skip down to this step that I'm writing right now, which would be 1 times sine of x is sine of x. Cosine of x times 1 is just cosine of x. And then kind of forget about all of this, because right here is where you're going to be looking at from here on. Unfortunately, we have to do the same thing with this term too. So you get the idea of what you have to do. We have cosecant of x is the same as 1 over sine of x. And then we're dividing by secant of x, which is 1 over cosine of x. Since you're dividing by a fraction, you multiply by the reciprocal, so that's 1 over sine of x times cosine of x over 1. And we're going to get down to where we're actually doing the problem, and you have cosine of x over sine of x. And again, if you can do all of this in your head, do it, but I did want to make sure you knew where it was coming from. All right, now we're going to do the same thing we did for the first problem and get the same denominators. To get the same denominator, I'm going to multiply our first term by sine of x over sine of x, and multiply our second term by cosine of x over cosine of x. So on my first term then, I have sine squared of x over cosine x times sine of x. My second term is cosine squared x over cosine x sine of x. And then we have our trig identities. Again, sine squared x plus cosine squared x is sine squared x plus cosine squared x is 1. Cosine of x, our denominator stays the same since we're adding fractions. I know that 1 over cosine of x is secant x, and 1 over sine of x is cosecant x. And I'm done. The rest of the problems you solve pretty much the same way that you solved the first two, but this last one is a little tricky because it has a lot more steps. The first thing that we would need to do is what we did with everything else. You just have a bigger part of it, and that's to get the same denominator. So in order to do that, we're going to multiply the numerator and denominator of the first term by sine alpha plus 1. To get the same denominator in the second term, we're going to multiply it by sine alpha minus 1. And this is just doing your foiling, first, outer, inner, last. So I'm going to go ahead and make my numerator sine alpha plus 1, and then I'm going to expand all of this out just so you guys can see what's going on here. First, sine theta, or sine alpha times sine alpha is sine squared alpha minus sine alpha. Then you do inner, which is plus sine alpha, and you can probably already see where this is going to go, and then minus 1. So that's the first term. Now we're going to go to the second term. Our numerator will be sine alpha minus 1 over, and then we're just going to go ahead and do the same thing, sine squared alpha, then inner plus sine alpha, then minus sine alpha, and minus 1. So you can see that this cancels out right here, and this cancels out here. So simply put, our denominator is now just going to be sine squared alpha minus 1, and then we have our two parts to our numerator. We have sine alpha plus 1, and then sine alpha minus 1. That looks weird. And that is all over sine squared alpha minus 1. I'm going to go ahead and work with the top before I get into the bottom and just cancel out what I can. I have sine alpha, and then this should have been in parentheses. So this is actually a minus sine of alpha, and then this would be a plus 1. But the sine alpha minus sine alpha is 0, but then the 1 plus 1, because you distribute the minus sign or the negative sign, a negative times a negative is a positive. So that's where I'm getting that from with this and this. So that's actually 1 plus 1. So you get a positive 2 in the numerator. And then now we'll deal with this denominator, and that's going to help us get to the end. If you know your Pythagorean identities, you know that, and I'm going to show my work over off to the side, sine squared theta plus cosine squared theta equals 1. I'm just going to use basic algebra 1 to make it look like this. So in order to get this, to make it look like sine squared theta minus 1, I have to subtract my 1 from both sides. But then I also have to subtract a cosine squared theta from both sides. So that'll be equals negative cosine squared theta. So that means I can replace this denominator with a negative cosine squared theta. And I'll put my numerator up there. Now we are very close to getting this final answer. I know that cosine square, a 1 over cosine squared theta is the same, and we should be doing alpha. I don't know why I completely switched that. I know that 1 over cosine squared is just secant squared, but I can't forget my negative sign, and I can't forget that too. So that's how we get the negative 2 times secant squared alpha, not theta. And this was a kind of difficult problem because you had to really work some algebra off to the side. And anytime you see a sine squared theta and a 1 in the same thing, you should think of that one Pythagorean identity, and that's just how you do it to get to it.